Okay, I think we're good. Hello, everybody. Uh, Sorry about that. I'm trying to cut down on the setup time for these, but yeah. And then actually, as made a comment near the end of that last one, I actually pulled it up. It makes sense. I was just getting tripped up with this modulo z at the very end, but as far as like adding y amount of these terms together chained, that's what I was getting tripped up on because I should have just moduloed z at the end of the for loop. So I think that would have made it okay. But anyways, let's go ahead and do this. Apologies, I forgot the link again. But anyways, let's see. A lucky number is a 10 base number which has at least a 6 or an 8 in its digits. However, if it has 6 and 8 at the same time, then the number is not lucky. Okay, so if 6 in string number and okay, I think that's all the conditions. Let's try. Boom. All right. Minute 38. Cool. So, I wonder why. I thought I changed the settings to where, like, first off, I thought I changed the settings to where that loud beeping wasn't happening. So, apologies about that, because I mean, I just heard it's still an ongoing thing. And then, as far as this goes, I didn't really enunciate what was going on. So, basically, you wanted to do the first check was the combination of, um, well, a couple of things I need to check here in a little bit. Um, So if it's 6 and 8 together, then it's not lucky. But if it's an XOR, if it's either 6 or 8, then it's lucky, and then everything else, it's not lucky. So, alright, cool. Let's jump right back into another one. Alright. Hmm. Yeah, and rather than mess with settings and everything on a live stream, I think I'll just try to look at it in between streams. But, um, anyways, I try to share my code whenever, anyways, unless I accidentally like start a clash and then get up and go do something else. I've done that on an accident a couple times, but you know, I try not to do that. So I guess like the noise notifications are useful, but that's if I'm trying to do like multiple things at once. Like when I was looking at this thing, trying to figure that out. In fact, let's just go ahead and just look. It'd be really nice if that didn't happen, or if I could figure out the sound settings, or I don't know. I'll figure it out. Anyways, all right. So, the link. Sorry. Your program must print the sum of the square of the numbers given as input. All right. So, sum equals 0. Sum plus equals xi times xi. Print sum. Yeah. All right. Bada bing. 37 seconds. All right. Yeah, I want to share the code there. So, I've actually done a challenge very similar to that before. All right, let's do another clash. Just keep them going. That's what, 2 for this stream? I'm going to try to get at least 4 in an hour stream. 6 or 7 would be even better. And that's how it was when I was doing the clashes off stream this morning. I got a couple of really nice ones that, I want to say like low hanging fruit, or, challenges I've seen before recently, or, something that just clicks. So, but again, I have been doing 150 of these, so if it looks like I've, oh, this is I'm just that smart or anything, I mean, chances are I've seen it. Yeah, GG's. That was good. Let me also clean these up too, because I want to make sure that I'm, well, one, paying attention to the chats, and two, paying attention to the correct chats. Alright, another fast. Ah, the link. I always remember right as I see that thing. So, alright. It's playtime, and you've accidentally scattered all of your favorite building blocks all over your bedroom floor. Bummer. Each block is a cube with side length equal to s. All of the blocks have landed on their own unique position on your bedroom floor, given an n by m map of your floor. Denoting the position of each block, can you determine the tallest tower you can build if you gather all the blocks up and play with them? Wait a minute. So first I'm trying to figure out what is a tower. Let's see. The first line of input contains two integers, n and m, representing the number of rows in the map and the columns. Okay, that makes sense. The next line contains the integer s. So it's like how many of these blocks can fit in the grid. Each of the next n lines contain m characters, either a dot or an O representing a block. Output a single integer representing the height of the tallest tower you can make with all of the blocks. Alright, so I guess we just need to count the blocks and multiply that by s, right? So, sum equals 0. Let's do sum for char in row. If char equals, what are we looking at? O's? O sum plus equals s. I did not get it first. I got it second. There we go. By one, oh wait, no. By 10 seconds. Okay. Yes, share the code. So let's take a look at that. So, yeah, all we had to do was find if it was a block and then add how big the block was, and then that's how big your tower is. So, okay. Nice. I guess I should leave the other clashes open if people. Although if you're watching the stream, you already know how to solve that one. No, I'm not a big fan of self-promotion, so I like to do this just because it's fun. I don't want to be like, oh my gosh, follow me. Well, anyways. Oh, and that blue screen of death. I love that picture. That's like scary. Yes. Anyone who's worked in IT or has owned a Windows computer that had things go horribly wrong, you've seen that. So. Ah, thanks for the follow. Named 1VN. Nice. Sorry, I'm horrible with names. And actually, I assume people are horrible with my names too. You got A-Rye, then you got Alex Gore. Basically, because my name is Alex and I play gory video games, so not like the politician. But also the politician off of like South Park and stuff. I love those South Park episodes. Alright. Oh, and the link. The link. Okay, so it looks like we're building towers, but if it's even, it goes up. If it's odd, it goes down, maybe? Yeah. So if it's odd, okay. If n modulo 2 equals 0. Pythonic code? Is that like a person, or are you talking he's a real coding nerd? I like to think a lot of us are coding nerds. We're hanging out, doing these clashes, but no, I don't know who Pythonic code is, unfortunately. Let's see. Else do turn string equals that. uh, for range n. Uh, okay, let's see here. Return string is going to be, oh, padding. Okay, so let's figure this out. So if it's odd, so for this situation, I think it's the easier one. So we would return string plus equals, and then let's do padding 2 equals. Sorry, I'm just having a little. I guess it shouldn't matter where I declare those, but basically my concept is padding is going to be an empty string, and then it's going to be asterisk, and then. Oh, actually, you know what? Never mind. If we don't, let's actually, let's cut this out. I got a much cleaner way to do this. So let's just do that. I figured that was kind of running away. Alright, so rather than doing that, we'll just do padding. So if it's even, padding equals that times n? Yes. Padding 2. And also, something to consider. Oh, looks like you don't have the padding on the end. Wait a minute. So for this one, padding is, if it's even, we got to start with that. Actually, I don't know if it matters, to be honest, because there's not a padding 2. And then for num in range n, return string plus equals padding plus asterisk asterisk, and it's just space, right? Plus space. Oh yeah, and I also need to do new line. Found expected. Do we need to chop it? Uh oh. Oh. Crud. Never mind. We do need to do this. Sorry. Let's do need to do this in each of these situations because we're incrementing and decrementing padding. So for like an even, we're actually decrementing padding. So this would be. Wait, no. Let's first do for even, padding equals that, and then padding equals padding with the last one chopped off. Alright, so that's going to shrink the padding, and it's still going to print that. Whereas here, you're going to do padding plus equals space. Alright, I think Okay, it's looking better. It's not quite, I mean, but at least now we've got like the actual concept down. Okay, so now I'm thinking, let's try the very first, the easiest sample. We got this. Found, expected. Why? Why are you... Should we do 2? Does that work? Although, actually, now that I say that, maybe we should just take out... Let's see. So if we take this out and just remove that, as well as do it here. End of line. So we do still need to chop that off. That wasn't... That's okay. That makes sense. All right. Is that all of them? Oh, okay. Now what do we... Found, expected. Okay, so we've got a... I thought I changed them uniformly. Oh wait, what's this? Nope, that's shrinking the pattern. Let's try some others. Again, we've got some leftover, um, white space. It looks like. And are these just on? Okay, so they're just on the even ones. So this one. Plus new line, padding equals, no, so that should be, see, I wonder, no, it looks like there isn't a space, a leading space, because what I was thinking is maybe if we initialized padding as a single space, but no, it looks like it goes flush up to there, and that looks like what ours is doing. So the problem, oh whoops, no, we need to actually get to, oh no, this is a problem in the, does. Wait a minute. Wait a minute. So we just have one too many spaces here? Oh geez. Times... Oh, okay, cool. So I just had to remove a space. Alright, reverse mode. I'm the last one. Alright, whatever. We got it. We got it. Okay. Let's share the code. We got 5 minutes short on that one. Alright, let's do another one. GG's, yes. I don't know. Anytime I actually complete it, I'm happy. I mean, like if I can do it in the 15 minutes, that's saying something. Because some of these challenges are pretty intense. So, although the cool thing with doing so many of these is you start to see some of the more intense challenges repeated, or at least the similar concepts, and then it's easier to do them, you know. So, or at least easier to get them done in the 15 minutes. I guess that's why I don't want to try any in Java or C++. Could probably even do JavaScript, but I would need more than 15 minutes. I mean, or maybe if I did it in Python and then translated it over, it's just the syntax of the other languages. Python makes it really easy to do things quick, so I've been spoiled with Python. I can't even imagine doing something like C. That would just... Well, I guess with a lot of things that we do, the difference between C and C++ wouldn't be all that bad. I don't know. I'm just rambling. Let's see. So, gotta make sure that last video wasn't as glitchy. I didn't have as many drops. Yeah. So, oh, link. There. Threw that in the chat. Alright, fastest mode. You need to find the number of rabbits there will be at year n, given the initial number nb of rabbits at year 0. To simplify things, there are no males and females. Every rabbit gives birth to g rabbits per year. Okay, but be careful because rabbits only give birth during the first 2 years of their lives. Rabbits, oh, geez. We gotta do conditionals. Rabbits only live 4 years. Um, Alright, I can already tell you this is gonna take me a minute, so, um, hey, what's up, time traveler? Welcome to the stream. Yeah, let's see. So, we got, hmm. So we're keeping track of births and deaths. First 2 years of their lives. Huh. Rabbits only live 4 years. Alright, so number of years, initial, then the number of new rabbits per rabbit each year? Okay, well, I mean, once we figure out the actual algorithm, changing or adjusting G or making G adjustable isn't going to be that bad. But all right, I'm just trying to figure out. So n, the number of years, and then we have. So does this also mean that year 1 and 2 are irrelevant? Or no, they only give birth during the first 2 years. So at n3, so at n3, the third year, NB amount of. Okay, so we'll do productive population and non-productive population. So if we keep track of those two different types of rabbits, and then, and that's just to figure out the first part. Then to figure out the dead rabbits. Oh, what's that movie? Sorry, I was just thinking that the Dead Rabbits is that Irish gang. It's like, anyways, it's got Leonardo DiCaprio in case you want to look it up. Anyways, so the productive population is actually NB, the initial. And for 2 years, so we're going to have to do this in a loop n times. So let's go and num in range n. Okay, so then we calculate it, and I'm almost thinking we should have a third category with like 4 years. Let's see. So we have a productive population of years 1 to 2 of that amount. And then after 2 iterations, that amount gets added to the non-productive population. Um, so sorry, I'm also trying to think. if we keep a running check, or if we're keeping track of, if it's the year of, well, I guess because every year, sorry, the rabbits are productive for years 1 and 2. So then on the third year and up, wow, sorry, it's gonna be cyclical, and it's gonna go around in cycles of 3 years. So on the third year, the productive population will be moved to, oh, wow, that gets even more complex because every year you're going to have a certain amount of rabbits become non-productive. However, that's not all of them. So it's only how much was added. So it's like NB times G at that situation. So you almost need to keep track of that, like how many rabbits were added each year, well, which we do. I mean, we haven't even gotten into that point yet. Um, so like for year one, year two, total. Well, no, as we go, the productive population is increased. Yeah, prod pop plus equals um, prod pop times G. Okay, the growth. That makes sense. And then I was thinking of another way to write that, like the times equals or whatever, but we don't even need to go down that road. We can just keep it with this. So, let's see. I guess the trickiest thing is just, if they only produce for the first 2 years and then die. We haven't even addressed the death cycle. So like remote. Um, I'm gonna do 2 count 0 and 4 count equals 0. So the method behind this madness, I'm gonna do 2 count plus equals 1, 4 count plus equals 1. So now we got to keep track of it on the back end. Um, huh. So, and I'm also missing 2 pieces of code. So basically, I'm going to be keeping track of 2 count and 4 count. So 2 count is going to reset every 3 years. Um, so the 2 count is going to affect the productive population by transitioning a certain amount of them, like something times G. Should even maybe do current G equals, well, we could do it 0 there, but I mean, just to initialize it, but then current G equals prod pop times G. And by, what is going on? Sorry, it's actually really dark in here. I should probably, I guess it's about that time of day. All right, times G. And my thinking behind that is, we'll keep track of that, and then we could, I mean, we could change it here, current G. Doesn't really matter. I mean, we could have left it, but that is in order to adjust the population to subtract the non-productive population from it and add that to, because we still need to keep track of the total population. So in order to transition the 3-year-olds into the non-productive population, every third year we need to. Mm, it's almost like we need to keep track of these the growths per year. There's a thought. Because every third year you remove the growth from 3 years ago. So, and then every 4 years you remove the growth from 4 years ago. But that one you remove it permanently. So, like the first situation, you're every 3 years. So once two count hits that three, and then it gets sent back to zero to do it again. Ah, okay. So actually, let's do that. Let's do glist. All right. So the growths every before we even do anything. Oh, wait, let's see. Current growth, and then glist dot append current growth. Current G. All right. So now we have. Now it's just a matter of adjusting it correctly with the growths. So that's a given. We'll always increase the population by that. That's the first step. Now the second step is transitioning the non-productives to the non-productive. So prod, pop, wait a minute. If two count equals to well, I guess we're just trying to eat up the first 2 years in this situation. So if two count greater than one, because it's zero and it's one, so two count will have to be two before we start doing that. But then once we so if two count is greater than one, prod pop minus equals so it's glist of two growths ago, right? Because it's that population that happened 2 years ago, like the initial NB. Yeah. And also we need to index equals 0. We need to make sure that we're doing index plus equals 1. No. Okay, so we're going to need an index glist minus 2. Okay, that should be good because that'll also, I guess we could have just done 2 count minus 2, but whatever. We have two indices keeping track of the same thing. But basically, so in glist, we have the growths per year. So that's always going to be that. All right, so I think we've got that situation handled. That should be working correctly. Now we need to handle the deaths. So if, same concept, if 4 count is greater than 3, because that would mean, 0, 1 through 3, then do it's not productive. Non-prod pop minus equals glist index minus 4. 4 indices prior, 4 years. Yeah, I don't trust that logic. I think there's definitely bugs possible, but oh, and then what are we doing? Non-prod plus equals glist index. Ah, dang it. All right, well, I'll go ahead and share that. I didn't quite finish it, but the logic was there. That was a pretty tricky one. I like that. Let's do some feedbacks. I like it. Fun. I really want to start actually doing vocal feedbacks of like what I. But anyways, yeah. So like that. All right, and let's clash again. Let's go. Yeah, we at least have time for another clash, if not 2 clashes. And then gonna do the same thing. Go get some coffee, have a snack, maybe do another one. I don't know. I still have 350 clashes to go until I hit that 500. So I also kind of want to start doing some puzzle solving ones. I might do that. 'Cause if you do, I don't want to lose my window. Like doing these puzzles. Oh yeah, puzzles, and then also the bot programming. Hello, my name's Jeff. Nice. All right. Oh, sorry, I forgot the link. That's my bad. All right. So let n be an integer. It is said to be palindromic if it is the same reading backwards. Okay, yeah, palindromes. That's got it. What? Base b prime. Okay, so that's probably one of the corner cases later on. Given an integer n in the usual decimal system and a base b, you have to say if n is palindromic in base b. Let's just check if it's a palindrome first off. Wait, guess I don't need that. Yeah, and I need to turn the light on. Actually, yeah, let me do that real quick. This is ridiculous. Apologies. I mean, yeah, I'm sure it looked cool with like the dark and the blue, but I can't see what I'm typing. So, all right. So that should check to see if that's a palindrome. I don't understand really yet the base thing. Else print false, and I guess I could have absorbed this one, but whatever. Um, let's try them. Yes. So that's the corner case. So we have 2 cases that we don't pass just by a traditional palindrome. So now we got to investigate this base nonsense. So let's go ahead and print what is B for these situations that we're failing. 24. And what's this one? 40. So I'm thinking, what are the bases on these? 10, 10, 3. So normal numbers and then a trinary. if I'm even understanding that right, because like a hexadecimal is a base 16, and binary is a base 2, and digital's decimal is base 10 for deci. But a base 24 and base, I don't even know what that. All right, let's see if we can figure it out. So, well, let's see what the number is actually. Um, let's see what they're talking about. So we're failing this one, and let's. God, get out of here! It's so annoying. Okay, so wait, let's try that again. In a base 24, that should be true. Oh, oh. If okay, I'm trying to see. I think I got it figured out. So if the number is smaller than the base, then it's palindromic because technically it's only one digit. Is how I think I'm understanding it. Now this is weird because it's like one. This is really 11 in base 10, but if this is a base 40, that's 40 possibilities and it's 41. So so there's. Hmm. Well, so for this condition, anything less than the base would just be palindromic because that's the equivalent of 1. Whereas this would be. Okay, let's go ahead and try to capture that one. If n is less than b, print true. We gotta take out this again. Okay, so we handled that condition. Now, in order to handle this corner case, I hate to say it, but we almost have to like restructure the entire logic. And the reason I'm saying that is because the situation here, the base is so this is getting a false true. Wait. Well, no, because n is slightly bigger than the base. It was 41 and 40. So in order to convert that, to the 11, which is a palindrome, you'd almost have to evaluate if it's a palindrome. Like, so do this. Ah, thanks for the follow, Mycon. Nice. Um, so in order to do that, you would need to evaluate or check to see if it was a palindrome after you convert it to a base 10. So it would even say, maybe even here, elif base is greater than 10. Maybe convert n into a base 10 number. Oh, but then that. I mean, this is technically kind of like hard coding. We can go ahead and try it because it's just for this situation. But number equals number modulo b. I wonder if we could even just do this. Oh no, no, that messes things up. So the base is greater than 10. So whatever that was. We lost one. Hey, hello, Mike and Douglas. Oh wait, are you on Also, what's going on here? Oh, shoot. Base like exponent. Let's see, how long ago was that? I haven't been paying. Okay, just a minute. So, um, oh wow, that threw me for a loop. Yeah, base two is very complicated because that's binary, so that's ones and zeros. Base 10 is 0 through 9. So yeah, um, the base means how many possible values a digit can be. Base 2 is binary, ones and zeros only. Base 10 is 0 through 9. Base 16 is equals to hex, and so on. There you go. Hope that helps because we still got 5 minutes as far as figuring that out. I'm trying to think of how to. So, what I was doing with this is I was weeding out these, two corner cases with these first two conditionals. So, I mean, if n, like anything where the number is less than the base, it's going to be a palindrome because that's the equivalent of saying 1. So, like 1 in base 2 is literally just 1. 1 in base 10 is 1. Actually, I think 1 in base anything is 1, so it's a palindrome, but um, well, that's a whole nother thing. But basically, this corner case would fit this condition, so then I wouldn't even worry about evaluating whether or not it's a palindrome. I know it's 1, so I just output true. And then this one, now I'm trying to take that other corner case and chop it down, although now it looks like I actually broke it. I'm trying to remember. Let's see. And actually, I was just reading my description again. That doesn't really help for base 40. Base 40 is just ridiculous. Although that's like, or base 64. In coding, how we do have a number system like that. But so, anyways, I was changing this back to an if because now if it's caught by these two corner cases, oh yeah, because I was about to copy this bit of code and put it in this elif because now I wanted to evaluate. But now I'm just, if the base is greater than 10, I want to chop the number to that to change it to a base 10 so I can understand it a little better, um, which make it a modulo. But now that broke test 2. Just out of curiosity, what would happen if I changed that to an elif? What? Okay, so never mind. We need to keep it that way. But now what are we failing with this one? Was this the oh. See, sometimes this stuff just makes no sense. 40 and 41. All right, so it's a base 40. So this is technically a 1-1. It's supposed to be true. Hmm. So that means this is not correct. Whatever I'm doing here, I need to change. Would it be? Yeah, I don't think I'm actually changing it to a base 10 number correctly. I think that's my issue right here. So, I mean, I got all the other test cases, so that's good. I'm not even worried about shortest. Like, oh, wait, what? Oh, because I'm printing that. Never mind. Like here, we'll do a little bit of shortest, but really not too concerned about that. So I guess I'm just getting confused with a bunch of Oh yeah, I think you're oh, let's see. You're not in this one, but I think you're the one that we've been clashing with earlier, right? I think so. Yeah, you've been inviting me to some. I've been inviting you to a couple. So, welcome. Hello from Brazil. All right, let's see. I think we just have to take a hit on this because I'm not understanding how to make this work. Because we got 40, so that is supposed to be a palindrome. I mean, without just hard coding, like, hey, if B is 41, output true. Like, no. Um, yeah, let's go ahead and be good with that. Oh, no. Let's see. Stop. There we go. Check the cases. Good. We're still most of the way. All right. Okay. 60%. Wow. That's pretty harsh. And I got the lowest character count of all of them. Oh, wait, no. Sorry. This one. They did better than me on that. So, well, I kind of want to do one more. I mean, we're still under an hour. Yeah, that'd be all right. Yeah, there. I invited you to this one. I don't know if you're currently clashing or not, but I think that's you. So, let's see. Wonder how many. Uh, I'm gonna see what my count is on how many clashes I've done. Oh man, better go quick. 164. Nice. That's not bad. All right. Oh, the link. Oh, sorry. Alright, fastest mode. Our reactor is equipped with 4 temperature sensors. It is common for one or more sensors to fail between 2 maintenance and refueling outages. It was determined by engineering that the second maximum value is the most representative and envelope value to protect the reactor. You need to code an algorithm that returns the second maximum so the control and protection system of the reactor became more fault tolerant. Um, well, I don't know what all that means, but we're going to do n list equals that. We're going to n list dot append wxyz. We got to append all of them, right? And then we're going to do yes w. Then I gotta. I mean, I think there's a cleaner way to do this, but I'm just doing this way. Then I'll sort the list and return the second one. Seems pretty straightforward. I, unless there's something I'm missing. Um, n list. Um, actually, yeah, it still doesn't matter. Dot sort. print. Okay, so one thing we do. Alright, so that does have to be included in the loop, but that's fine. So print end list. And now we need to figure out, so it's always going to be 4, let's do 3. Nope, 2. Let's try that. No. Alright, but it looks close, so... One. Hmm. 109. Let's try doing it this way. Okay, and now let's do, because it wouldn't be at position 3. Ah, alright. 108, 109. Hmm. Well, those don't even matter. We gotta figure out the actual... So these are unsorted, and then they need to sort. So I think my sorting is just not working. Let's see. So we're appending them all to a list, and we're trying to. Hmm. A lot of people giving up. Huh. All right. So. Okay. I'm gonna try that. So we got 109. Oh. Wait a minute. Yes. There we go. Got it. Alright, so what was going wrong is I wasn't reinitializing the end list. Oh, it's fastest mode. There we go, submit. I was about to start making it all short. We're still less than an hour. Let's do one more. Why not? Maybe we'll get lucky and do like a little like quick 1 minute one. So yeah, so basically by not reinitializing end list to an empty list, it had all of the ones jumbling up in there. So of course it wasn't going to be in order. All right, let's see. So fastest. The ABA, the Abacaba pattern is a recursive fractal pattern found in many areas of mathematics. Oh gosh, I have seen this before, but yeah. And the real world. The first iteration of the sequence is the first letter of the given character set. Or I think I've seen this before. I don't know. It looks familiar. To generate the nth iteration. Hold on. Take the previous iteration, add the next character of the given character set, add the previous iteration again. So wouldn't that be like A, B, A, C, A, B, A? Oh, wow. Jeez. Uh, anyways, let's see. Output the nth iteration of the Abacaba pattern using the given character set. Ah, so we're going to make it even more complicated. You can't just calculate this one. Okay. So if the character set is ABC, we're doing 3 iterations. So the first one is add the next character of the given character set. So since there is no previous iteration, add the next character of the given character set. So is that automatically starting with 2 characters? Is that how they get the AB of the abacaba? Because then you start over and you add the character of the previous. Then you add the next one and it. So it's abacaba decaba. Oh, jeez. Hmm. Maybe I should have called it quits one time ago. Alright, let's see. This is confusing. Let's all get out. Maybe I haven't seen this before. So let's go back to these clues. Oh, also I can't see the chat rooms. Sorry, in case if anyone's chatting, although it doesn't look like anyone is, but apologies. Yeah, very funny this match. This one is very funny. I should almost say that. But all right, so we got three things to create this sequence. Well, first we're gonna have return string because we're gonna be building stuff, and then we have to find the nth. Oh yeah, we have to output the nth iteration. Okay, so we have to build this string n times, or n steps. Okay, so I guess I just don't get it. Like, I don't. 'Cause you're starting off, so first iteration, you have A. Second iteration, you add B and A. Okay, okay, so for num in range n, turn string plus equals character set at position num plus return string. Is that it? That might be it. Let's see. Bada bing, there you go. Okay, I figured it out. Alright. Oh, that was fun. We're still just barely over that hour, but that's alright. I'm gonna take a break. It's probably gotta be close to getting to dinner time, so I might eat some food and then do a couple more clashes, I think. I don't know. I'm having a good day. So alright. Well, thanks for stopping by, everybody. Hope you enjoyed, and I will see you in the next one. Alright. Ta ta.